Hello everyone, I am Dr. Rajesh and I am again with you with my next video lecture, and this video lecture is on the topic Kepler's law of planetary motion. So as the name indicate that Kepler's law are regarding the planetary motion. So there are three laws of Kepler of planetary motion, and the first law is given by the orbit of every planet. Say this is a planet. The orbit of every planet is an ellipse, and this is the ellipse with sun at one of the two foci. As we know that ellipse has two foci, focus number one and this is focus number two. So sun will be present at one of those foci. So say here sun is present and this is the planet that is revolving around the sun in elliptic orbit. So that is the statement of the first law, that planet is revolving around the sun in elliptic orbit with sun at its one of foci. So it is revolving around the sun in elliptic orbit, like you are saying that it is revolving around the sun in elliptic orbit. So this keep on revolving in the elliptic path. So this is called the first law of planetary motion, that planets revolves around the sun in elliptic path. And if we say when it revolves around the sun and it reaches over here, you see this distance of planet from the sun is minimum. That distance is called perihelion distance, and when this planet comes from here to here, you see this distance becomes the maximum, and that distance is called aphelion distance. So these are two distances. Perihelion distance is minimum distance from the sun and aphelion is the maximum distance from the sun of the planet. So these are the two distances, and this is the major axis of the elliptical orbit and this is the minor axis of the elliptical orbit. This is the planet, and you see from this figure it is also clear that this is the sun and the planets are revolving around the sun in elliptic orbit. So first law is concerning regarding this only, that the planets are revolving around the sun in elliptic orbits with sun at its one of the foci. So next we move towards the second law of planetary motion, and that of Kepler's. So second law of planetary motion is here. So what is the statement? It states that a line joining a planet and the sun, the line joining the planet and the sun, this line sweeps out equal areas during equal interval of time. So let me make you understand this thing. Say this is the planet revolving around the sun. So here it is time, say 0 day, and in 10 days it comes from here to here. This describe this much distance. So what sectorial area it has covered? This is the sectorial area it has covered, and this is shown in the blue region. So next it moves that much in 10 days. So after that it goes and here it reaches, and say here is time also 0 day, and in 10 days it comes over here. So it covers that much sectorial area. So both the sectorial areas, according to this, sweeps out means this sectorial area sweeps out this sectorial area and this sectorial area, because it is swept out in equal interval of times. Equal interval of time is 10 days. This is also swept out in equal interval of time 10 days. So therefore this sectorial area and this sectorial area, both sectorial area are equal. So that is the statement of the second law of planetary motion, and that of Kepler's. So once again I am reading out this statement. A line joining a planet and the sun sweeps out equal areas during equal interval 10 days of time. So that is the equal areas in equal time. So this is the second law of Kepler planetary motion. So now we move towards the third law. So this is the third law. Third law states that the square of the orbital period of a planet, orbital period is denoted by T, and it is the time taken by the planet to complete its one cycle. Let us say planet starts from here and it describes the complete cycle around the sun and comes over here again. So that much time, whatever time is taken, is called time period, and this is say T. This is T, and this T square is directly proportional to a cube, where a is the length of the semi-major axis. So once again I am reading out the statement: the square of the orbital period of a planet is directly proportional, square means t square, is directly proportional to the cube of the semi-major axis of its orbit. So cube of the semi-major, this is the major axis and this is half, so this is semi-major axis, cube of the semi-major axis. So this is the third law of Kepler, that t square is always directly proportional to a cube. Now we move towards what is the role of Kepler's law. So this is the first law. Once again summarizing: orbits are elliptical in shape, that planet is revolving in elliptical path around the sun with sun at its one of foci. Equal areas in equal time, equal areas in equal time. This is second law. Square of the time period is directly proportional to cube of the semi-major axis. This is the third law. So what is the role of Kepler's law? These laws have a wide variety of application in the modern physics, which makes the Kepler's law of planetary motion very important. These laws are mainly used for the objects which are related to the outer space, like artificial satellites. So mainly Kepler's law are used for outer objects only, like artificial satellites, planets, etc. To study them, we make use of the Kepler's law of planetary motion. So it has got importance there, and it has got huge importance there. Now besides that, we will also study what is gravitational law of masses. So gravitational law of masses states that any two masses in this universe attract each other with a force F, which is directly proportional to which is directly proportional to product of their masses, and which is inversely proportional to square of the distance between them, which is directly proportional to product of their masses and inversely proportional to square of distance between them. And we introduce a constant g, which is called gravitational constant. So this is known as gravitational law of masses. So why we have discussed it over here? Because in the next video we will be deriving an equivalence between Kepler's law of planetary motion and gravitational law of masses. Means we will be deriving Kepler's law from gravitational law and gravitational law from Kepler's law. So we will be deriving them. So this equivalence we will be proving in the next lecture. So in this lecture we have studied the Kepler's law of planetary motion, Kepler's first law, Kepler's second law, third law, and we also studied what is the importance of Kepler's law of planetary motion. So that's all I have from this lecture, and in the next video we will be discussing the equivalence between Kepler's law and gravitation law. This is very important question, and that's all I have from this video. If you have liked the video, please like, subscribe, share and comment. And this is Dr. Rajesh saying goodbye, take care and see you soon.